Good morning, sir. Good morning, everyone.
Hi, good morning, everyone. All right, let's wait for a couple of more minutes while we have others joining in. Yeah.
Yeah, that works. Good morning, everyone. Mm. Are we good to start, Sujay, or we are waiting more?
I guess we've already waited for 10 minutes, and considering that we have around 140 participants, we can get started. Yeah.
Great. Perfect. Thank you so much. Hi, everyone. Very good morning to all of you. Is it like the chat box is disabled for me? Okay, no, it's working. Somehow I'm not able to click on the chat box. Okay, it's working. All right. Hi, everyone. Very good morning to all of you. Yes, good morning. Good morning. Please acknowledge with the thumbs up quickly. Yes, okay. Confirm your presence by a thumbs up so that I come to know that yes, my audience is active, loud and clear in the chat box, Sarthi. In the chat box. Great. I can see 56 thumbs ups right now. Well, good enough. And now let's move on to our fourth day, quickly discussing upon the agenda that we had anyways planned. So on our fourth day of learning, what do you essentially have in place over here is one notebook on governance, scaling, resilience assessment. That's going to be the starting point for the day. So in fact, I would prefer to get this created right away. So that's going to be the very first thing I have to put in. The second thing that we are going to look after that is today we'll be getting into the evaluation framework. So evaluation of the rack pipeline, which we have already covered, but there are some other metrics which are there in your table of content. We shall be touch basing upon them as well. Then there is one more notebook on benchmark regression about LLM as a judge. And finally, you have a notebook on observability, logging, tracing, debugging. So that's going to be the fourth notebook that we will be covering. Right. And post that, on the fifth day, there will be around two more notebooks that we have to cover. One will be related to the token economics cost optimization, and the next one would be related to the FinOps Gen AI governance sector. So that's exactly how we aim to go ahead with this. All right. So now, moving ahead, let me quickly get in the things in place. So selecting the right kernel. So the next notebook. So what is this notebook mainly about? This notebook focuses on deciding whether your Walmart retail assistant is truly ready for large-scale production deployment. If you recall, the notebook that we completed yesterday was talking about reliability as well as security. This notebook is going to talk about the remaining production concerns. So what all are the remaining production concerns? Well, the remaining production concerns that we still have, they are governance traceability, scalability, cost control. We have the SLA, SLO measurement, failure resilience, rate limiting, and the final deployment approval. So the main business problem is Walmart may receive millions of AI-assisted customer interactions. Therefore, simply generating correct answers is not enough. As we understand now, we have that much maturity to understand that the system must answer questions like which model and prompt produced a particular answer, which documents were used as context. can a simple can simple questions use a faster model and a cheaper model? Very important. Then coming on to the latency, our latency and availability, uh, are these meeting the agreed targets? Then how do we stop one session from sending excessive requests? And based on all the controls, should deployment be approved or blocked? So what this notebook essentially builds up is the data governance and the lineage. So every LLM call is going to record information like the request, session ID, prompt version, context usage, success, failure. So that's going to create an evidence trail for audits and customer complaints. The second is scaling and latency management, right? So we will be looking into two things mainly in this notebook. The first thing is we'll be looking into the model routing, where simple questions can use a simpler model, complex questions can use a stronger model. I did talk about it on the second day. Today is where we are going to look into it. Second thing is you talk about streaming, where answers appear gradually instead of making the customer wait for the complete response. Just like in ChatGPT, when I type a question, it starts printing, and you get a feel of, you get a perceivance of lower latency, although it is still in the process. So it starts printing, so you can parallelly start reading around it. And the third thing here is the batching concept, where multiple independent requests can be grouped for background workloads. The third thing we look into is the SLA and the SLO measurement. So in our system, we will be mainly measuring P50, P95, and P99 latency. We will be looking into availability. We shall also be looking into the blocked request rate, and ultimately the SLO breaches. The fourth thing after this that we end up looking is going to be resilience and the graceful degradation. So if the primary model fails, the assistant follows a fallback chain, right? So if the primary model fails, smaller fallback model. If that also fails, then some cached response. If the cache was a miss, then some safe static response. Then the sixth thing that we talk about is the rate limiting. So, we are limiting each session to a fixed number of requests around, I guess it's a 60-second window. So this is going to protect against the abuse, accidental loops, etc. Then we have the final deployment readiness assessment, where I'm going to combine the notebook IN07, IN08, IN09, and generate a final deliverable, which is the deployment readiness assessment, which I mentioned over here, consolidating the checklist score from 7 and 8 into the final deployment part. So that's how the overall things are going to happen in this scenario. All right. Let me do the necessary imports. Once I've done the inputs, let's move on to the section number 1. So data governance, lineage, versioning, and the audit trails. In simple words, whenever Walmart assistant is going to give answer, the company should be able to trace which model answered, which prompt was used, which data was retrieved. We should be able to look into all of these things, how long each step took, and which user requested it. All of these things we look into it. And this complete history is what you call as lineage. So you look into the model version as the very first point over here. So the system should record exact model version used, because newer models may produce a slightly different answer. So if a customer complains, the team can reproduce the answer using the same model version. So this is going to help the performance before and after the model upgrades. Then is the prompt version. So the system prompt should also have a version number, because a small prompt change can affect thousands of future responses. So, version 2 may say answer helpfully. And the version 3, which I updated, says answer only using the retrieved Walmart data. So if the answer quality changes, the team can identify which prompt version caused it. Third is the retrieved context. So the system should record which documents or database records were used to create the answer. So that's going to basically be providing the traceability. Like, for example, if the policy is giving the wrong written policy answer, right? If the assistant is giving the wrong written policy answer, then the team can check was the correct policy document retrieved, etc. The fourth is air temperature. So what is temperature? System should record temperature, not only temperature, other parameters like maximum tokens, timeout, top P, even the model routing choice, because higher temperature produces varied answers, lower temperatures gives more consistent answers. So without storing these parameters, it is difficult to explain why the model behaved differently. Then the next point is the latency per step. So here it says that instead of recording only the total response time, it should also measure the individual stages. Like, what I mean to say is maybe, it should come up with respect to the latency per step. I would say it should be like, okay, input validation took 20 milliseconds, retrieval took 350, LLM generation 1.8, output guardrail 100 millisecond. And this is very, very helpful because it will help you to identify the bottlenecks. You can exactly find out where exactly was the problem occurring. And see, this is very, very important for SLA as well as the SLO monitoring. Then the last one, I guess, is the user scope. So the audit trial should, not trial, the audit record should capture who made the request and what they subscribed to access. So this is what we are looking into it. So, a very simple lineage record is going to look something like this, right? Have a look at it. A very simplified lineage record. And if you follow this, then I have a question for you. Whose answer will be coming in the chat box. A customer reports that the chatbot gave incorrect written policy answer. Which lineage information helps to identify the source document used? How can it be temperature, guys? Well, most of them are saying correct. Temperature can't be there. Temperature is just for variance in the output, right? Whether you want creativity or not. The right answer is option number B, because retrieved context shows which document or which policy document or which data source supported the answer. Yes, so that's one which is option number B being the correct one. Yes, well answered, everyone. So now we get into the data lineage tracker. And what are we having over here is, see this lineage tracker, what all are we actually measuring over here? We are measuring the following things over here. The first one, we measure which prompt version was used, which model answered, which context documents were provided, how many tokens were consumed, how long the call took, and whether it succeeded. So as you can see over here, the prompt registry that we have, it's a dictionary for storing different versions of the system prompt. So if the assistant behavior changes, we can identify which prompt version actually produced the response. So the active prompt version, which is currently selected, is 1.1, right? That's what I did. And I want you to read both of these prompts. I'm going to pause over here so that you can read version 1.0 and 1.1. Going ahead, because I was able to finish reading, so I'm assuming you also completed. Next, here is where I have a function call with lineage. So it's going to accept the user input, session ID, which is the current conversation identifier, context documents, and the model. And then we are going to generate a request ID, which is going to create, this UUID4 is going to create a unique identifier. Only the first 8 characters are kept out of that. It's going to be a lengthy one. So only the first 8 characters. Then I'm loading the active prompt using the prompt registry. Then I'm capturing the starting time. I'm having messages over here. Now, if you see into the messages, first of all, system prompt is added. Then I'm checking whether the context documents exist, right? If it exists, then all of this, this CTX is equal to, what are these? These are mainly going to join all the documents. So like, for example, if you have the first document saying that milk costs $3.98, second saying written policy is 90 days. So it will be joined together, all of these values. And when no context exists, only the customer question is sent. That's what we are doing. Then we are giving a call to chat completions of OpenAI, getting the answer, calculating the input output tokens and success equal to true, calculating the latency. And then, as we can see in the lineage record, typically, what are we having? The first 3 are the request ID, session ID, timestamp. That's understood. Next 2 is the model and the model provider. That is also understood. Prompt version is also understood. Now, what are these 3? Which is the prompt hash. So this prompt hash, typically it is going to create a short SHA-256 fingerprint of the prompt text. And why both version as well as hash is being used over here is, version is going to create a readable label, no doubt about it. But hash is going to prove the exact prompt content was used. So then we have the input hash. And this is exactly where we are actually storing the fingerprint of the user input rather than the raw text. So this will help us in identifying the repeated request without storing the complete question. And the reason, see, plain hashing, to be very honest, is still guessable for common inputs, but the key hashed or HMAC is safer in production. Then this is the place where I'm getting the context document IDs. So each context document is converted into a short hash. Then I'm having the remaining parameters, which we all understand by default, appending it to the lineage record and returning it. So if you see, I have the test case. Green value whole milk 1 gallon is priced at $3.98 and located in aisle 12. Walmart return policy 90 days window for most items with receipt. So two trusted context documents are being provided. And I'm calling. What is the price? S01 and context documents. So each customer question. Then first is the question. The second is the session ID, which is S-001. And the last is the context. Let's see what it answers. I'll print the complete response. Well, that's correct. It's $3.98. Request ID is given a unique number, first 12 digits. Latency, request ID, session ID, timestamp, model version, provider, model, prompt version, prompt hash, input hash, and all the other things. Right. Then the next thing is about scaling and latency management. That's the next topic, right? So here I am mainly going to explain you how Walmart Assistant can handle very high request volumes while keeping the cost and the response time under control. So let me tell you over here, we are proposing 3 strategies: batching, streaming, model routing. What is batching? Batching means you are combining multiple independent requests into one API call. So, it's like instead of sending 100 separate product classification requests one by one, the system is going to group them together. Then, report generation. It is also best suited for offline evaluation and non-interactive workloads. Abhijit, we are going to do that as well using the Langfuse. If you recall the outline that we discussed, right? We have Langfuse for traceability. Stay connected. We'll be coming to that. So then the main benefit of batching is better throughput, lower request overhead, and potentially significant cost saving. The second is the streaming. Right? So streaming is just like ChatGPT sending the answer tokens, token by token, as and when the model is generating it. So without streaming, the user will have to wait for the complete answer to be ready, and then only it will be flashed. With streaming, the first part appears immediately. So this is best suited. Streaming is best suited for your interactive chats, long answers, customer support conversations, because there is, or it reduces perceived latency. Then you have the model routing, which is going to send the request to appropriate model. So basically, if it's a simple query like what aisle is milk in, it can go to a smaller, faster model. But if I say compare two return policies, interpret an exception, and resolve my order dispute, well, then a stronger model is required. That's what we have being talking over here. So depending on the strategy, following is the table. And depending on this, there's a question for you as well. Take your time and then answer it in the chat box. All right. I can actually see a unanimous output over here, which is 27 streaming. Yes, it starts showing the response before the full answer is finished generating. That's absolutely correct. So with this, I'm gonna go ahead. Here I'm using a simple model GPT-4o mini, complex model GPT-4 turbo. And I am also creating some complex signals. So what are these complex signals? Basically, see, these are the regex patterns which indicate that the query may be complex. Like here, when I say R, compare versus, so it is detecting phrases like this, compare versus vs, etc. Or, it is detecting questions like why, explain, how does, basically all reasoning or explanation related questions. Then the third one is it is mainly focused on complaints and disputes, right? Then policy related questions, then multiple item questions, all of this. Then I'm having a classify complexity, which is a very simple call, convert the query to lower and see if that pattern exists. You can also use another LLM over here, but here I'm using regex so that I'm able to save the cost further. And this will return either simple or complex. So you can see, there's a huge role of regex. There is no need to go for any model or something. If you can just populate the right regex, you end up saving a lot of cost in the production. That's exactly what I said, Krishna. That's exactly what I said. You can do that also, but you can save upon that simplest model cost as well if you create a perfect regex, right? So both of these are valid approaches. And going for a simple model is definitely a good and a viable option, can be considered. I went even simpler than that because the main aim of this notebook is also token saving, right? So with that vision, I have done it. But feel free to tweak it based on the budget of the project. All right. This is where I'm having a routed call. So it will be getting the user input session ID. It will classify the complexity. That means the call goes over here. Obviously, it will return me either simple or complex. And depending on that, I will call that lineage with that particular model. And that call with lineage is the function which we already discussed about. है ना, ये वाला अभी डिस्कस किया था, call with lineage. So you will pass that kind of model. And then after this, yeah, here is where we are asking questions. What aisle is in the milk? And it will be printing which route it took, which model it chose, etc. Let's see it on the fly again. Starting with it. As you can see, what aisle is the milk in? Latency is this, model chosen is mini. Can you compare the nutritional profiles of great value whole? GPT-4 Turbo is what is being chosen. And so on. It is going ahead with the next one. I want to dispute a charge on my order. What is the refund latency? GPT-4 Turbo. What is the store hours? GPT-4o mini, and that makes quite a lot of sense, right? So we are able to handle these things in quite an intelligent way. The second one is the streaming. Now here, streaming is pretty simple and straightforward in action. So now I'm going to display the LLM response gradually as it is generated instead of waiting for the complete answer. So the main benefit is the lower perceived latency. Total generation time may be similar, but the customer starts seeing the answer early. So that's what we are doing over here. And it's nothing but the model used, and we are just streaming the output, right? There is nothing new over here. It's the same thing. Again, you're using the model and you're streaming the output. So if I ask what is Walmart return policy, you can see this is how it went. And let me just see, are we printing the complete output? Stream response. Yes. Max tokens is 150. So you can see over here how it went, right? It started printing left to right. Once again, if I show you, you see it started printing left to right, and I can start reading around it just like what we expect in applications like ChatGPT. Then after that, the next thing is our section number 3, which is SLA, SLO definition and measurement. Now, why is this important? Because SLA, which is service level agreement, this is an external commitment made to the customer or the business holders. Like, we saying that the service will remain available at least 99.5% of the times. SLO, which is the service level objective. Now, this is stricter internal engineering target. So internally, the team targets 99.9% availability. So SLO is usually stricter so that the team has a safety margin before an SLA is violated. So P50 latency, which is the median response time. So SLO is below 800 milliseconds and SLA, let's say, is 1200 milliseconds, less than 1200. So if P50 is, let's say, 700, half of the users receive the response within 700 milliseconds. That's what it means. Similarly, you have P95, 2000 and 3000 respectively, and P99, 4000 and 5000 respectively. Then availability. How is that calculated? Successful request plus total request multiplied by 100. Right? Sorry, successful request divided by total request multiplied by 100. Then you have the hallucination rate. Then you have the blocked request rate. Error budget, which is the amount of failure allowed while still meeting the SLO. So for 99.9% availability over the 30 days, allowed downtime must be 43.8 minutes. So if the system uses this downtime budget too quickly, the burn rate becomes high. And these percentiles matter a lot. With this, I would like to ask you a question, right? Let me see, what do you get from this quickly? There you go. If the P95 latency is 2.5 seconds, which statement is correct? Very interesting. Yes, that's correct. The P95 SLO is below 2 seconds, while the SLA is allowed up to 3 seconds. Perfect. Great. So now let us get into the SLO measurement framework. So here we are measuring whether Walmart Assistant is meeting the internal SLO for latency, availability, and the blocked request rate. So I'm setting up the targets over here. So you'll have to only change these things. What am I essentially saying over here at a higher level is I say that my P50 latency must be at most 800 milliseconds. In the same way, I say that my P95 latency must be at most 2000 milliseconds. My P99 must be at most 4000 milliseconds. Similarly, it says availability must be at least 99.7% of the time. And block rate must be at most 1%. So I'm creating a measure SLO. First of all, here I'm checking whether it's an empty input, right? So that is what we are checking. Then next thing is here, what are we doing? We are basically converting the latency into milliseconds. Then I am gonna sort it from the fastest to the slowest. Sorting is necessary before the percentile calculations. Then I'm finding out the total number of calls using the length function. And then this is where I have created a function which will calculate a simple percentile. And after that, I'm counting over here the total count, right? So I can actually say that the count of successful and the locked calls is what we calculate. And then you have all the measurables, right? So all these measurements come into picture like a dictionary. Then after that, you compare the results with the target. And based on that, you have some rules in over here that if you say if latency in metrics OK is equal to measured less than equal to target, which is indirectly I am trying to say that lower latency is better. So the measured value must be less than or equal to the target. Then availability in the metrics where I'm looking at higher availability is better. Right, that's one thing. And lastly, for the last scenario, else scenario, we are like for block rate, lower is better. So we are capturing those. Then after that, I want to make 50 calls using the lineage and the synthetic data. So I am, it's like you imagine that I am simulating the production calls over here. So C is equal to 42 is going to generate values which are, the generated values will be repeatable so that the notebook is able to produce a simulation each time. 45 normal calls are going to be there because I have given for I in range 45. So the latency is generated around mean around 0.8 and standard deviation of 3.5. Similarly, below I am, here, this is the place. This is good. Yeah, this is the place after this where I'm trying to prevent the negative latency. So that's one thing which I have handled over here successfully. So Gaussian distribution can generate negative values, right? So this code is enforcing every latency to be at least 0.05. And then before I run this, I have an interesting question for you all. What does one failed call, why does one failed call reduce the reliability to 98% in this session? Meanwhile, I can run this. Interesting. Yes. See, with only 50 records, each individual represents 2% of the total. So the answer B is absolutely correct. Yes. Thank you for your votes over here. Yes, the answer B is absolutely correct. The next one is resilience pattern, fallback chain, or and graceful degradation. So just give me 10 seconds. Huh? All right. So I was saying the next one is the resilience pattern. So here we talk about how the Walmart assistant should continue working even when the primary model fails. So let me tell you, the goal is not at all to expose the technical errors to the customer, but somehow we want to move to the next available option automatically. That's why we are calling it as a fallback chain. So, attempt one could be using a primary model like GPT-4 Turbo. This is preferred because it is going to give us the highest quality answer. And if it succeeds, the response is returned normally. If it fails, maybe because of timeout, overload, or maybe some API error, the system moves to the next option, maybe a smaller fallback model like GPT-4 or Mini, right? This is called as graceful degradation because the system may reduce the answer quality slightly, but the service remains available. The third one is the cache response. I could see one such question in the chat box. So it is about the cache response, which means if the model fails, the application checks a cache or a static knowledge base. So if I ask a question, what is the general return policy? The cached answer would be most eligible items can be returned within the defined policy window. Simple. So that is useful for questions like what are the store hours or general return policy or some contact details, frequently asked questions. But a cache response obviously may not be perfectly current. So it should be used only for approval or stable information. And the last one is a hard-coded safe response. If no cached answer, then the application returns a fixed message like service is temporarily unavailable. Please try again shortly or visit walmart.com, something like that. Right. So that's the main idea in between. So these are the main differences. Fallback is move to another failure. Graceful degradation is continue service with reduced capability. Retry is call the same failed service again. And cache is return a previous policy stored answer. Yes, so that's obviously true in this case. Okay, and I see there is one relevant question over here. Like it says this should be complemented with the circuit breaker as well. Yes, absolutely. That's 100% correct. Fallback, retry, cache, graceful degradation, followed by a circuit breaker. But the circuit breaker solves a different problem. It is going to stop the system from repeatedly calling the service that is already failing. So yes. Also, the second question, which is very relevant, which Ayush has asked, I'm going to take this also by myself. So how cache response will be useful considering each query, even being semantically same, might have different language. Yes, that's absolutely correct, right? A normal exact match cache may not help when the user expresses the same meaning. I agree. So see how caching works is instead of comparing the exact text, the system converts the query into embeddings and then checks whether its meaning is close to the previously answered query. And when the similarity is high enough, the cached answer should be used, not in all the cases. So that's a very, very valid question. All right. Then there is one more which I think is relevant, so I will prefer to take it, where Nitya says that can all these questions and answers be summarized to a FAQ for reference? Well, not really possible. Not really possible in all the cases over here. See, logging and everything, you can't do that. Supervisor calls and all. So it's not completely possible, I would say. And what if the answer is not in the cache? User might think the application is hallucinating. Yeah, absolutely. Therefore, I said, right, we are having a graceful degradation step by step. If it is not available, live model service is not available, then the system should not guess an answer, right? So why are we talking about this entire flow? We are saying that in that case, it should return user-friendly error, service not available. बताया था ना? Hard coded, if cache is not available, say service not available, hard coded graceful response. Look at the fallback step by step. Attempt 1, 2, 3, 4. Right. Going ahead. Now here is where we are actually creating a fallback chain, as you can see. So see, what is the fallback chain? Let me just put it before I take it ahead. Primary model fail hota hai to smaller model. Smaller model if failed, cache response. If nothing is found in the cache semantically similar, then graceful default message. Right? So I am creating some response cache. Graceful default. I mean, if nothing works, then I am temporarily unavailable to process your request. Please visit walmart.com or call this for assistance. Then this is the cached lookup function. What are we doing over here is it is going to search the cache for a matching question. You can, of course, do the embedding similarity calculation in this scenario. So here I'm looking for the keyword at the very first place. You can do keyword comparison, you can do embedding comparison, you can do a hybrid comparison of both. Very much possible. Then this is where I am calling the model, right? And then the model will be giving us a response. Now, if this API call fails, the function does not catch exception. It allows the exception to move into a fallback chain. You might have seen it over here. We'll be doing all these things later, but here is a fallback chain where it is clearly creating a list of records which fallback stages will be succeeded or failed. Like the first attempt is the primary model, right? And so on. It moves ahead, second attempt to a secondary model, then a cache model, and then a graceful default. That's what we are doing over here. Primary model call. If failed, fallback. If failed, cache. If failed, graceful degradation. And then we are testing what is the return policy for electronics and what are the store hours. As usual, I again forgot to remove this. So I'll be rerunning it. So first one was GPT-4, second one was GPT-4, and you saw over here that it is not failing in any of the cases because the model is available. But obviously, if it failed, then only you should be able to see it. In our case, we understood how to implement it, but yes, there is no graceful failure observed. Then the next one is the rate limiting per session. Very, very important. Per session we are talking about. So what am I going to do here is, in this code, I'll be limiting the session to 20 requests within any rolling 60-second period. So it is going to complete the rate limiting gap identified in the IN07 notebook. So first of all, we are importing all the required data structure. So default dict is for automatically creating an empty value for every session. DQ is DQ, right? It is mainly for storing the timestamps efficiently and allowing the old timestamps to be removed from the front. Then as you can see, I'm setting the rate limit window sec to 60, rate limit max calls to 20. What does that essentially mean? I mean to say that one session can make maximum of 20 calls during the last 60 seconds. And once it is done, the 21st request within that period will be blocked. Then session call times, as we can see. So this is going to mainly create a separate DQ of timestamp for every session, right? To store the request times per session. Then so basically, you know what, this DQ conceptually is going to look something like this. Session 1, DQ, time 1, time 2, time 3, session 2, time 1, time 2, and so on, right? That's how it's going to look. The respective times would be there inside it. That's just the syntactical structure. Then we have the rate limit function. Now this function is going to take the session ID, right? And it will return whether the new request is allowed. So first I am calculating the current time. Then I'm saying that, okay, window start is equal to now minus the rate limit window sec. I'm calculating the beginning of valid 60-second window. Like if the current time is 12:01 and the active window is 12, right? Something like that. Then the calls is equal to session call time. This is where we are getting the number of times a call has been made. And then this while loop. This is for removing the expired request. So any request which is older than 60 seconds, flush it out. Why are you going to keep it? So while calls, what are calls? Check whether that queue is empty or not. Calls of 0 is going to look at the oldest request timestamp, oldest one. And then pop left is obviously going to remove that if it triggers. Then we have if length of calls greater than rate limit max calls. So if the session has already 20 valid requests in the current window, the next request is rejected. And we return it after that. Finally, we are post that we are returning it. All good. And finally, I'm just simulating one burst from the session. 22 calls, right? I am giving it purposely to see whether it fails. Rate limiter burst of 22, calls 21 blocked. Calls in window 20, retry 60 seconds. Total calls are this. So this is exactly where you can see how we were able to do that. See now, if you see the output that we got, it represents, it actually repeats the code rather than showing the actual execution result. I understand that, right? The output that you see on the screen, it is only and only repeating the code, but it is not showing the actual execution result. Based on the logic, the expected result is 20 allowed and 2 blocked. You have to give the calls. I have not given it. The aim was to show you the concept. LLM call can be given. 20 LLM calls at a time. It's going to increase my cost as well. I didn't give it. And I think this is enough for anyone to understand the concept as well. Right. So my suggestion, right? See, this works in one Python process. In a distributed production system with multiple servers, listen to me very carefully. Whenever you are having a distributed production environment and you have multiple servers inside that, the request count should be stored in a shared system such as Redis or maybe an API gateway. Otherwise, each server would maintain a different counter and the user could exceed the true limit. If you followed this, time for knowledge check. So the question is, which request is the first one blocked when the limit is 20 calls per minute? Come on. I can see I have started receiving responses in the chat box. And yes, everyone says it is option C. The first 20 calls are allowed. So the call number 21 or the 21st call is the first blocked request. Absolutely correct. The last section of the notebook. This is where we talk about deployment readiness assessment. Now, see, we have total 3 notebooks that we have looked into, 7, 8, and 9. IN 7, IN 8, which we completed yesterday. And the 9th one is over here. And this is just stitching the things together. So here I'm going to combine the results from the previous notebook into one production readiness score. So the aim is to answer one question. Is our Walmart retail assistant ready to go live? And I'm going to do this assessment on three domains, right? 3 assessment domains. The first is, as you see, reliability and observability, right? The notebook is IN07 and the maximum score was 12. I want you to remember it. You can't say, sorry, I forgot, right? It was there on our GitHub. I think Control Shift P, opening the GitHub here, and day 3. And we are talking about IN07. And here we had mentioned about this, reliability and observability. The maximum score was what? 12, right? We had input validation, output guardrails, hallucination check, audit logging, and whatnot. The next was security. That was our 8th notebook, or I would say the last notebook that we did yesterday. I'll keep this open over here. Here, the maximum score was 9, I remember. So here we look into prompt injection detection, jailbreak resistance, PII masking, exfiltration controls, content moderation, and all other things. And right now, the current notebook that we are looking into, which is our notebook number 9, IN09, it is including data lineage, prompt model versioning, model routing, streaming, scaling controls, SLA, SLO, fallback chain, graceful degradation, rate limiting, final audit evidence. So essentially, the total comes out to 30. 9 plus 9, 18. 18 plus 12 is 30. And I have decided the final decision to be like this. What is like this? This means below 20, block the deployment. 20 to 25, conditional approval, and 26 to 30, approved with monitoring. See, this is what my brain worked upon. See, you are free. You are free to design it the way you want it, the best which I can think. I am one person, right? If I'm working in a team, maybe I come up with additional more awesome pointers as well. Similarly, when you work on this, you consider this notebook 7, 8, and 9 like a roadmap, not like ironclad notebooks that I cannot change anything over here. Depending on your use case, you can definitely do plus or minus to it. The aim is to understand the approach. I am not offering you any consultancy service where I'm solving your business problem. I am here to explain you how the things work so that you can take it ahead from here in any of your real life projects. So always keep that in mind, right? Don't all of a sudden ask a question that, hey, but in my project it is like that. Of course, that's quite obvious and commonsensical that it will change based on project to project, architecture to architecture, but the fundas remains the same. If you know ABCD, you using that you can create words. If you know words, you can create sentences. If you know sentences, you can create paragraph. If you know paragraphs, you can create essays. If you know essays, you can create a book, right? Now, what essays you write, what book you write, whether your subject is history, English, literature, that's completely okay. Fundas remain the same, right? So please understand this thought process. Right. So, going ahead. Here, I'm just straight away copying the score from the notebook 7, hard coding directly, to be very honest. You can create everything in a single notebook. And we are just setting all of the scores over here for notebook number 7, notebook number 8. And okay, this is going to fail in my case because this JSON I have not taken. Just a moment. I will have to copy those JSON files which I created. Hold on. The two JSON files are, where are they? Did I delete it? Oh yeah, it's here. JSON and JSON 7 and 8. Let me copy it inside the day 4. Yeah, now I copied it. See this one, what we created yesterday. This one, what we created yesterday. Same here, nothing out of the box. I'm just gonna get this thing from here. Right. So these were the scores. We have already computed it yesterday in these notebooks. If you recollect, यहाँ पे end में we got this 9 on 9. And if you recollect, यहाँ पे end में we got 11 on 12. So this all we dumped it into the JSON, right? If you remember this, यही use कर रहा हूँ, same thing. So I read it from here. Then with respect to our current use case, did I do all of this in notebook number 9? Of course, I have done it. So I'm just setting it to true. These are like the checkpointers, right? And then finally, I'm just stitching everything together, right? Taking the minimum of this comma 12, minimum of this comma 9, minimum of this comma 9, and calculating the total points out of 30, how much. And based on that, I have written a verdict what it will be for various scores exactly as per the table which I showed you above. And then I'm just printing it in a little nice stylish way for you below. Right? So it's a detailed report which I have printed, which you can share with the manager. Right? So that's good. Taken from this, taken from this. So you see, we have created a complete data pipeline, right? This is how data engineering comes into picture, and we got finally a total score of 29 on 30. So it is approved with continuous monitoring. Interesting, right? It's really interesting. And I want to save finally into one final text file. So I'm going to save it. Deployment readiness assessment. Saved it. And of course, where is it saved? It is saved here only in the form of text file. So जो हमने देखा एकदम structured way, right? It is saved in a very structured way. Life is awesome. Summarizing this. Just go through it by the time we get ready for the next notebook. Okay. Creating a new notebook now. And let me quickly but before I go ahead with this, are you all with me? Please confirm in the chat box with a thumbs up to my yes message, right? Sequentially studying everything, making sense to each and everything, right? So there are many things which we are like, yes, we know it, but we understand now in what order they have to be implemented. Yes. Great. I can see a lot of thumbs ups to my yes message. Thank you so much for acknowledging. Hey, by the way, I can see there are 200 plus people. I know some people are little bit, what do you call, they have that inertia to open up the chat box. We are hearing to you, Darshan, but don't expect us to open the chat box. Unless and until we have a question, we will not open it. Please take out some efforts. It's been almost 1 hour, 16 minutes. One time you can open the chat box for me and acknowledge. है ना? After 1 hour, 16 minutes, एक effort तो बनता है ना? Yes. That will just help me understand that, yes, my audience is with me. Right? Great. Perfect. Yeah, I'll do that. I'll do that. That's a good option. I'm gonna do it right now only, Jishnu. Just a moment. You know, when I have to copy paste it first time, I will have to remove the env file. Just a moment. I'll do it right away. Give me a moment. Participant day 4. Copying it. Pasting it. Then this JSON can be removed. This can be removed. This can be removed. And this is where my GitHub is. I will have to upload the folder. I'm going to refresh it because I did it. As you can see, day 4, notebook number 9, added successfully. I'm not adding the JSON files and all. When you run the code, they will be produced. Right? So if I add it, then it will not make sense. Better you produce it, tweak around with it, play around with it, and then we'll take it ahead. Oh, yes. Thank you, Shakti, for acknowledging. So yes, notebook is being shared, everyone. And thank you for updating me. Okay. But I would strongly urge you to focus on the session rather than executing the notebook. Notebook 100% it will run. If it ran on my system, it will run on your system because all the exercises which I am executing, I have tried it in the virtual lab because it went perfectly on the virtual lab. We created replicas of that virtual lab. So if it ran on that machine, obviously it is bound to run on your machine. If you're doing it locally on your computer, you may face little bit plus minus things if the environment is not configured properly. Else, it's all awesome. It will run for sure. I'm sure you might have executed the earlier 6 notebooks, so they are running perfectly. All right. चलते हैं. Next. So now, what are we doing over here? Evaluation of RAG, but you're like, Darshan, we already completed RAG. Yes. We already evaluated RAG. Yes. So what new over here? Well, some other metrics, as I told you, right? And I'm not creating a RAG pipeline, my dear friends. I'm not creating a RAG pipeline. Assume that we already have a golden data set, which anyways we only create. Assume that we have the predictions that we got after invoking the RAG as well. And then here we are simply comparing the expected and the predicted and try to understand the metrics around it. Don't forget this. So no RAG. So I'm doing the necessary imports. The model will be used, and the judge model which I'm going to use over here is the GPT-4 Turbo. The first thing is I will have to create a golden data set, right? What is the golden data set going to comprise of? We create it, right? Our question, then the context, which is what should be expected inside this, expected answer. As a human, what answer I expect to this question? Like if I ask what is the full form of SPIL, the answer should be SPIL's full form is Sirca Paint India Limited. Expected tool, because we are also going to add agentic RAG later on. And then finally, you have the category, right? The query belongs to what type? So we need golden data set. And I have created a golden data set of 20 records. And here it is for you. 4 records for price. As we can see, let's read through one of it. ID, category, price. What's the price of great value whole milk? And the context is this entire thing which we got from the retrieving part from the PDF or the context. Then expected answer is this. And the expected tool. We have explored all of these tools. It's continuation. You know, we are actually studying a story of agentic AI production. वही चीज पहले वाली repeat हो रही है. And that was covered in our day 3 only, as far as I remember, when I showed you single agent versus the multi-agent. In multi-agent, we have added several tools, right? Search product, check inventory, get policy, get order status. So similarly, these 4 are more related to price. In the same way, the golden data set consists of 4 records related to the policy. Yes, context is also created by us. Yes, it is not coming from the PDF. From the PDF, what comes are the chunks and the invoking results. So that's absolutely correct. So, okay, there's an interesting question over here by Vishal. And we already discussed it, but I'm going to give you a heads up on this once again. In production, number of files can be high. Yes, as high as 10,000 PDFs. So how do you do it in production? You have to take smarter steps over there, Vishal. If I would have been in your place, then I would have used a hybrid approach. I would use any other large language model for generating questions and answers from the PDF. And then I will just invest time in validating it via some other large language model. Plus, some of the answers I would validate by myself also from each of the category. That's a way I can improve the speed. Another thing is you keep on doing everything manually, right? So honestly speaking, it is we only who have to do that. So we can do it in a little smarter way for sure, is what I can say. Right? I hope that gives you the answer. All right. So you have this thing. Usually we save it as a JSON-L file or JSON file and we read it. But here, because there are only 20 that I have created, I can straight away do that. And you can see I've just printed how many from each category are here with me. And after invoking the RAG pipeline, what are the real answers? These are the real answers to each of these. The first answer, because we discussed only this, Great Value whole milk, 1 gallon cost $3.98 and is in aisle 12. By this point of time, we should have memorized this. And in this way, we have got the 20 real answer, not real answer, the predicted, the invocations. So I'm gonna run it. And here I'm just manually checking, manually, we are not doing anything, manually checking over here, how many of them are exactly matching. Just I did that like that only. This is time pass basically. You need not do that. So 3 of them are exactly matching. All right. So then let's move on to section number 2, output level evaluation. So in the output level evaluation, we can say it is going to measure the quality of the LLM's final response. It does not look at how the answer was retrieved, but only at the answer text itself. And there are 3 metrics which we are going to implement in this section. And the one which you already know, I am not going to invest a lot of time in that. And that makes sense also. So the first one being the faithfulness. Have we not studied that? Of course, yes. I'm going to just skim through the most important pointers, maybe 10-15 seconds on this. And rest of the things you can study from here line by line. I have given you awesome understanding of everything mentioned over here. Faithfulness measures whether every factual claim in the generated answer is directly supported by the provided context. It contains no invented facts. If the answer is faithful, there will be no invented facts. And the way you do that is simply number of claims in the answer that are grounded in context divided by the total number of factual claims in the answer. All the metrics will give you a value between 0 to 1. Higher the better. Expect at least 0.8 or more in all the metrics. Right? 1.0 means every claim is supported. 0.8 to 0.9 minor extrapolation acceptable, and anything below 0.8 problems, right? Not acceptable. Also, I have given the ideal values by use case for retail, policy, general, medical. So you can see more or less it is 0.85 on an average. General FAQ, I have kept it as 0.7. Again, it depends on context to context, but these are good educated guesses for you to remember what's the bare minimum that we can expect. Going to calculating it. So here I have created complete faithfulness. What are we doing? I'm giving the context, which is the ground truth, which we had already obtained. Answer to evaluate. Task, list every factual claim in the answer. For each claim, see, I'm not using ragas. I'm not using ragas. Ragas is using these formulas automatically. Here we are doing it from the scratch, maybe using LLM as a judge. So I'm explaining LLM what is faithfulness, and then I'll ask it to judge. Right? For each claim, state whether it is directly supported by the above context. Then compute the faithfulness score as grounded claims upon total claims and reply in JSON format. And also tell me the grounded count, total count, and the faithfulness score. Or catch life is sorted. Giving a call to the judge model. You are factual grounding auditor. Be strict and precise. And I give the prompt which we created here. And we get the result in the form of a JSON. And here I'm going to test it on 3 golden records here. And let me see how many times is it passing. I'm only testing on 3 of them, first 3 precisely. You can try on all, of course, but obviously 3 calls, right? So it will take some time. That's the reason I didn't. For 20, you can understand it's going to take a lot of time. And for the first 3, we got a faithfulness of 1.0. In Ragas, I also explained you answer relevancy. You can see that we have all of this when we actually covered it on our day 2 in the RAG evaluation and monitoring. See here also we created a golden data set. So ye kiya hai humne. We have already done that. And then after that, before the Ragas, I gave you a lot of conceptual understanding about everything. See here, we discussed context precision, context recall, context entity recall, noise sensitivity. We talked about response relevancy, faithfulness, answer relevance, accuracy, context relevance, response groundedness. And I told you there are several other metrics as well. So here we have the answer relevancy already discussed. Again, you expect, we'll just read one line about it. It measures how directly and completely the generated answers address the specific question asked. A relevant answer stays on the topic and does not include unnecessary information. No, we are not deriving it on our own, Ashwin. We are not deriving it on our own. Here also we are using the same technique. What did we do over here? On the day 1, if you remember, Ragas was the second approach. See here, Ragas was the second approach. Before Ragas, I did show you the first approach, which was LLM as a judge. Here, if you remember, we used the approach of LLM as a judge. This one. So I showed you both the approaches. Now here, I'm only talking about LLM as a judge approach because we are not, see, have we created any rules? Like for example, faithfulness. Faithfulness is calculated as number of claims divided by total claims. Have we really compared it word by word anywhere? No, I'm simply saying that LLM, you take this, you do this and you tell me, right? So we are not doing it from the scratch here as well. Ragas does it. Here, LLM is used as a judge. All right. So now we get into the answer relevancy. Code remains the same. As we can see, all of these things are given where we are asking that, hey, I wanted to find out the answer relevancy. So what is answer relevancy? I'm giving some additional context and explaining it. Does it answer what was asked? Is there necessary off-topic content? Are these aspects of the question covered? Whatever you want, you can write what you mean exactly by answer relevancy in your use case, and LLM will be doing that for you. So I'm again trying it on the first 3 only. And we can see we are getting a score of 0.9, 0.9, and 0.9 for the first 3. The third metric, which we did not discuss, but it is quite obvious, is the toxicity score. You can read through it here. Just read through it. Give me 10 seconds. Fan on kar. Toxicity score. Right. And OpenAI moderation API, you remember it, right? So here We want the toxicity score less than 0.1 for all the production responses. So what is more important over here? If you see, I'm using the moderation API. We had seen that yesterday only. Moderation API is going to get the category scores and the categories. From that, we are rounding off the things. And here I'm being very specific. Agar score is greater than 1.0, mark it for review. Else you say pass. That's exactly how we did it. Then we are asking, I'm purposely asking some toxic and some non-toxic. So if you see here, the first one, great value milk, normal. Second one is also normal. And the 10th one is a toxic one. Let me show you G010. Upar jao and let me show you G010. Interesting. I added it purposely. So my order has not arrived. It was supposed to come yesterday. And what was the answer which I added? According to our records, order this was delivered on 1st July 2026 at 2:14 p.m. and left at your front door. A photo confirmation is available. If you cannot locate the package, please contact the customer support. This is the actual answer. But what the rack predicted? What the rack predicted over here is 010 right here. Order this was marked delivered on July 1st at 2:14 p.m. to your front door. If you still cannot find your order, that is your stupid mistake. A delivery photo is available. Toxic, right? That is toxic. So I'm trying out that, and you can see the first and second are 0 in toxicity, and this was 0.5. Action blocked, flag is true. Interesting. Next, we also have retrieval level evaluation. So retrieval level evaluation measures whether the vector store, vector database is returning the right documents for each query. Context, right? So even see what were we doing in the RAG pipeline? We retrieve the top 3 chunks from the vector database, and those top 3 chunks and the query was sent to the LLM. Before sending to the LLM, we need to evaluate whether the vector database is working as expected. And here, again, I propose to you 3 metrics, and these metrics are exactly as per there in your table of content. I can add n number of other metrics, but I am sticking to it. And you don't need all of them also, of course, but the most important ones are already covered. I also covered it, and this also further touch bases upon additional metrics. So this should be more than sufficient. Hit rate. Hit rate measures whether the correct document appears anywhere in the top K results. So it will answer questions like, did the retriever, right, the retriever QA, find the right evidence at all? The formula is number of queries where the doc is in the top K results divided by the total number of queries. So obviously, K, as I told you, right, we'll prefer to keep it as 3, as you can see, and any of these values are acceptable. At K is equal to 3, minimum acceptable is 0.75, production target should be 0.88. K is equal to 5, minimum acceptable, production target is 0.93. Ideal values by use case that you should try out in your scenario would be 3, 3, and 5, as I told you, right? Remaining things, of course, you can read it. So this is where let us go ahead and compute this thing. So what are we doing over here is the very first one. The very first one, I am creating a function to calculate the hit rate for one query. Right, so this function is going to return 1 if the relevant ID is there in the top K IDs, else it would return 0. Right? Then after that, as you can see, this function, evaluate hit rate. So this is the function to evaluate the complete data set. I showed you on 3 examples, right? Now this is on the complete data set. So I'm creating an empty list. Then I'm iterating through all the records So it will be, every record will contain ID, category, and the question. And then here, after that, here I have simulated the retrieval, right? I have simulated the retrieval. Why? Uh, Purposely, right? Because I don't want to invoke a RAG call. I only focus on the evaluation in this notebook. I don't want to implement it in the RAG, else it will take a lot of time. And we have already discussed RAG in detail. So it does not make sense in once again adding it. So in real life, it is going to be a RAG call. So the POS, right? That's where we are selecting the position where the correct document is inserted or will be inserted. So possible zero-based positions are 0, 1, 2, 3, 5, and 6. So position 0 appears 4 times. So it has a higher chance of being selected. You can see over here. Position 1 appears twice. Therefore, the simulation assumes that the retriever usually ranks the correct documents near the top. That is what is the assumption over here. So I'm creating simulated retrieved docs as well over here. Right? Simulation. I'm creating 7 dummy document IDs. In real life, you'll be getting it again from the RAG chunks. Then I'm also replacing, see, you see over here, line number 12. This is where I'm replacing the one of the dummy document with the correct document ID. So once this is done, I'll go ahead and calculate the hit rate for the record. This is the standard formula for calculating the hit rate, which is already mentioned over here. And then I'm finding out the sum of it, of course. Right? This is the overall hit rate which I'm calculating, which is the number of successful retrievals divided by the total number of queries. So let's say 15 out of 20 queries retrieved the correct document in the top 3. So hit rate is what? 15 upon 20, which is 75%. So this is where you can actually play around with it. Then if the value comes out to be above 0.75, pass, else fail. So we did it and we just calculated the hit rate. As you can see over here, this is what we got over here. So what do you understand when you look at this output predominantly? The first thing it says, hit rate at 3 is 0.8 and threshold as 0.75. So how did it get 0.8? 20 questions were there, which means 16 questions. For the 16 questions, the correct document within the top 3 was retrieved. Therefore, 16 upon 20 is 0.80, which is higher than the threshold of 0.75. This is what it is saying. Then here, ours is 1.0. So basically all the 4 store hour questions, right? There were questions related to the store hours, right? All of those questions retrieve the correct document in the top 3. In multi-step, 3 out of 4 multi-step questions succeeded. In order, all 4. In policy, only 2 out of 4 policy questions succeeded and 2 missed. And the price, it is 3 of 4. Right. And therefore, I would like to add on one important business interpretation. Overall system passes, but the policy retrieval is not good. This is important because policy questions may involve returns, refunds, warranties, eligibility conditions, time limits. So the correct conclusion is the retrieved system passes overall, but it should be considered fully ready. It should not be considered fully ready without investigating and improving the policy category. Right. So going further, the next one is the MRR. What is MRR? Mean reciprocal rank. It measures how high the correct document is ranked in the retrieved result. Unlike the hit rate, which is only calculating hits, here we are calculating the rank, right? That's the formula for it. Of course, you need not remember that. I myself don't remember it, and it's not required. Even if you remember it, it is guaranteed that you are going to forget it in a day or two, because we have a lot of other things to remember. So practically, what is important is the usage of it. Valid value, what we expect over here is 1 means correct document is ranked first. 0.5 means it's on an average rank. So 0.8 is a good value to go ahead with. Some minimum thresholds, but the production target, as you can see, is the bare minimum that we expect is being added over here. Then here, that's the code for computing the MRR. Again, over here, we are computing the MRR, and the most important logic for computing MRR is over here. Right, this is the most important line. Rest all of the things are same like the before one. So I'm calculating the average reciprocal. Uh, I'm calculating the average reciprocal rank across all the questions, right? And I am gonna return in the form, right? So that's the only thing which I am doing over here. As simple as that. So when I actually print this MRR results, what do we actually understand? Here, MRR is 0.467, which means the system achieved this MRR, but the required was what? 0.65. So the retrieval ranking fails. This means that the correct document is not appearing high enough in the search. What will you do? You go for re-ranking the documents, and that's exactly where a re-ranker rank comes into picture. We don't have it in our TOC, else I would have definitely discussed, and we don't have that much time as well. But I can give you a heads up, right? You can use a cross encoder model for re-ranking. Cross encoder model. Even when you put these things into any Copilot or ChatGPT, it will give you the perfect code for that. In fact, the notebook which I have given, if you put into maybe ChatGPT and ask it to add with the logic of a re-ranker, it will give you the perfect code. Cross encoder, make sure you're giving that hint. So that should be sufficient. So the main issue over here, is that 8 out of 20 queries, for 8 out of 20 queries, the correct document was not present within the top 3. Although 7 queries rank the correct document first. So that's what we observe over here. Then the next is precision at K and context precision. We discussed context precision, and now precision as K is nothing but out of the retrieved top K documents, what fraction are actually relevant to the query. The production targets for this are 0.8 and 0.7. Again, over here, we are not taking any additional steps, but we are doing that. Important point, lower precision K means noisy retrieval. So you can fix it by similarity threshold, adjusting the chunk size, and adding a cross encoder or re-ranker model. As I told you, right, same things over here. So that's where I have calculated the precision at K, where K ka value I will give it. Then you are having the compute context precision logic over here, selecting random data. And we are simply saying that if the final comes out to be more than 0.55, pass, else fail for precision 3. 3 and 5 are the most common values, by the way. Similarly, context precision. And this is what we are calculating. Now that was all about RAG. The next one is agent level evaluation. So having water, just a moment.
So here, agent level evaluation. It goes beyond the normal individual LLM responses because agent can take any path depending on the query. And here we have three most important metrics to be discussed. The first one is the task success rate. It's mainly about whether the agent completed the user's intended goal end to end, right? So it's a binary metric per task completed or not completed. So this is calculated as the number of tasks completed successfully divided by the number of tasks attempted. Expect a value again to be bare minimum 0.8, for production grade at least 0.9. Ideal values and the production target. Now, task success rate is the most human relevant metric. A user does not care about faithfulness or MRR. They only care about whether they got their answer. And therefore, this is one of the most important metric. The second is tool accuracy. Of course, we will be having the code for this as well. So actually, this is the 7th, and the 8th one is the tool call accuracy. That's correct. So here in the tool call accuracy, it measures whether the agent selected the correct tool for each step. And if the multi-agent, multi-tool agent selected the wrong tool at step 1, it will have completely cascading effects in the later steps. So it's calculated as the number of steps where the correct tool was called divided by the total number of tool calling steps. Again, as you can see, the minimum acceptable value is 0.85. Ideal value is greater than 0.95 for production grade systems. Tool call accuracy degrades when the tool descriptions are ambiguous or the tools are overlapping. Didn't I talk about it? I remember one of you asked a question that if there are two similar tools, like one is doing the Google search using Tavili API, another is doing the same Google search available, maybe using your SERP API, or you're also having a DuckDuckGo search API, or you're having a Bing search API, so many things. So you are confusing the agent, right? So in this case, you are going to get a bad score for the tool call accuracy, and hence these questions make a huge impact. The next one with the code for it. All right. So here I have created a function which is going to evaluate the agent, and it's not about document retrieval only. Three metrics is what I'm going to calculate. The first one is the task success rate to see whether they completed the user task. Second is the tool accuracy to see whether the agent selected the correct tools or not. And the third is the step completion ratio. Step completion ratio. Did the agent complete all the required steps? So that's what we mainly look up over here. So, okay. There is a relevant question by Vijayendra over here. Actually, you asked it little early, but let me take it quickly. If the company needs to validate the accuracy of the response given by the application, should the user feedback also needs to be evaluated against the different metrics we discussed, or take up the user feedback without evaluation? No, that would have been the blunder. See, for example, let's say Vijendra works in OpenAI and I work in Google. And I am very much jealous about the OpenAI model, and I want to bring down their service. I want to bring down their popularity, and I want to bring Google at the top once again. So anything which I ask to OpenAI, it is responding in a very awesome way. But I'm giving a thumbs up. I'm giving a thumbs down. I'm giving a thumbs down. Good response, thumbs down. Good response, thumbs down. Bad response, thumbs up. What is the moral of the story? Can you accept the user feedback as a direct proof of accuracy? You should not. That's a very important signal. You need to validate it. User feedback alone is not enough, right? User can give thumbs up, maybe because answer was clear, fast. He may also give thumbs up because he felt the answer was confident or it matched what they expected, right? But the answer may still contain incorrect price, policy data, n number of things, right? So you asked for someone's phone number and the model answered. User was happy. He gave a thumbs up. But do you mean that such kind of things should repeat? No, of course not. Hence, not recommended. All right. So here we are evaluating all of these three metrics. Sum of task results divided by the length of task results. And then I am simply saying if the values are coming above these all, we are going to say pass versus fail. And that's what we see in over here. Finally, the complete evaluation of all the 20, right? Okay, before that, we have a relevant question. And this question is by, and I just take some of the questions, right, where I think it can be answered by me directly, quickly, and they are relevant to the notebook immediately. Can we trust, Sneha says, the consumer or the developer feedback for the developer agent? Yes, we can trust the developer feedback more than the general user end feedback for sure, because developer can actually judge whether the code is useful, readable, and technically stable. But again, it should not be treated as the only ground truth, Sneha. Developer may approve the code because it looks correct or it saves his time, but the code may still have hidden bugs, maybe some security vulnerabilities. Possible, right? Anything is possible. Incorrect library usage, there could be some missing test, violation of internal coding standards. So the best approach is you have to use it with an objective validation, right? That's very important. So coming on to the full evaluation. And here, let me evaluate on all the records in the golden data set. Let's say initially, let's do it on 3 only. You can try on all so that we can save out some time. And all the functions which I created, right? Faithfulness, answer relevance, toxicity, ready. These are ready. Then the scores for each of this I am adding over here. The hit rate and all also we have computed from the above. I'm just going to pull it from above. We are not calculating anything over here. I'm just pulling it from above so that I can dump it into one JSON file, and I can print over here the first 3 values validation for you. It's in the process of doing it. It takes time, right? That's the reason I tried out on only 3. First 3. Summary of everything. Saved to JSON. You can try it on the entire golden data set as a part of exercise. You can try it on the agent as well. And this is the summary of what we have covered in our notebook number 10. As an obvious part of it, I'm opening my day 4, uploading this. Done. With this, the next notebook that we are going to cover, that's an easy one to be very honest. And Let me create the one. We'll do it after the break, of course, but at least I would like to get the kernel and everything ready for this. So here, we are going to discuss benchmark design, regression testing, and LLM as a judge in this notebook. Right. So now, as I always say, if you have any kind of questions, we have 3 teaching assistants in the class. They will be happy to take up your questions during the break time as well. If you have any questions, feel free to put it in the chat box. We will surely be taking your questions. And before we actually proceed on a break, let me quickly confirm from you all. Can I assume all good so far? Are you all connected with me, understanding everything that we are discussing? Please acknowledge in the chat box to my yes message if you are. Yes, that's perfect. I can see the thumbs ups increasing. All right, half century over, 58 now. Great. Fine, friends. So yes, that is it for now. Now we can proceed on a break and I'll see you all in 20 minutes. As I told you, if you have any questions, we have TS. They are good enough to take your questions. Feel free to put it into the chat box. Once I'm back, of course, you'll be seeing my camera on and I'll be seeing you there in the class. Thank you so much and see you in 20 minutes. Bye.
Hi everyone, we are starting in a minute. Please stay connected. In 1 minute, we get started. All right, everyone, welcome back. Okay. We are good to continue. And okay, you can see the error. API key may be deactivated. That could be the main reason behind it if you are facing the same issue. Yes, I think Abhishek should be able to help you out over here. All right. So let's get started with this. The next notebook. What is this notebook about? See, this notebook checks whether a new model, prompt, or rack configuration improves the Walmart retail assistant or makes it worse. Simple. Right? So you're not learning as such anything new over here, but as I told you, here the assistant will be handling questions related to product prices, locations, return policies, order tracking. So the main problem which this notebook aims to solve is, suppose Walmart is currently using one model and wants to replace it with a newer or a cheaper model. Then in that scenario, the company cannot deploy the new model only because it is faster or only because it is less expensive. So what all it must verify? Well, it must verify, are the new answers still accurate? Did any category become weaker? Has the response time become better or worse? Did the token usage cost increase? Should the new model be approved, reviewed further, or be blocked? So, as a part of the notebook workflow, the first thing that you see over here is LLM as a judge, right? So over here, as we all know, the same thing I would say, a separate LLM is going to act as an evaluator. And then it is going to score, right? It's going to score, like a score of 0 means it is wrong or harmful, unrelated. And 3 means it is complete. Then we also have a benchmark data set. So I have a fixed set of test questions covering the 5 categories: price, policy, order, store, and the multi-step questions. Then here we have the baseline evaluation. So baseline evaluation means the existing model is evaluated first. Results come from the baseline. You calculate the answer quality score, latency, inputs, token, input and output tokens. And then the baseline represents the current expected performance. Then after that, the next is comparison evaluation, right? So we then evaluate another model, maybe like GPT-4 mini, using the same benchmark prompt and judge. The 5th step is about regression testing. So what am I going to do is I'm basically going to calculate the delta, which is the comparison score minus the baseline score. And the idea is very simple. If the delta is positive, performance improved. Delta is near 0, performance remains stable. And negative delta means performance became worse. Then after that, it will conclude finally with a go or no go decision, whether it is approved or conditional approved or it is blocked. It also considers latency, token usage, because a slightly better model that is much slower or more expensive, again, may not be the best choice for production. And lastly is the comparative judging. This is what you have. If you have got this thing, get started and help me answer this question. Why should the same benchmark questions and the judge model be used for both the baseline as well as the comparison runs? Exactly. Yes. Changing the question or the judge would change the measurement condition. So the two model scores would no longer be directly comparable. Hence option B. All right. Let me quickly get into the imports for this. And then we have LLM as a judge. We know this technique. I'll go on to the understanding part of it. This is going to get me a score on the basis of speed, cost, consistency, scale, and nuance. Because human speed wise, humans are going to take days to week. LLM will take seconds. Cost wise, deploying humans to understand each and everything and rank, it's going to be heavy. LLM cost is only the API cost. Consistency over here would be deterministic. Here it won't be. Scalability, it is unlimited. Here it is limited. And nuance is high. And here also it's high with a good rubric. So 0 to 3 will be the rating for our Walmart retail assistant. 0 means it is harmful. 1 means partially correct, and so on till 3, which means complete and correct. One most important point that is quite obvious, you know it, but you should remember it. Whenever you are using judge, don't make it creative, right? Use the same judge model for the comparisons. You should also be aware of positional bias. In the sense, some LLM tends to prefer first answer shown. So you should mitigate that by the order of the questions in the comparative evaluations. And you should also be aware of verbosity bias, because some LLMs keep on answering longer answers rather than focusing on the quality. So these are the important pointers that you need to remember. So these are really very important in all aspects. All right. First approach, judge model GPT-4o Turbo, judge temperature 0. You can see, I'll just pause over here for 10 seconds so that you can read through it. Okay, then after that, let's go through it. So I have created LLM judge function to which I pass the query, context, expected answer, and the actual answer, plus the judge rubric, which is created here. You're giving a simple client call, right? API call. Your strict retail AI quality evaluator, follow the rubric. Temperature 0. You get the score. Then you're normalizing the score, right? So essentially you will be normalizing it in the range 0 to 1. And then I'm also going to get the label for the score, right? Correct but incorrect, whatever labels we gave over here, right? 0, 1, 2, 3, wrong or harmful, partially correct, etc. And I'm also going to get the reason over here. Then after that, 3 demo sentences. What is the Then I say, what is the price of great value whole milk? Then you have the context and expected. Again, you have the correct answer, hallucinated answer, and incomplete. So I'm going to try out all the crisscross combinations of each of this. So the first one, 2 on 4, normalized as 0.667, correct but incomplete. Second one, wrong or harmful, response is factually incorrect because it didn't answer as expected. And the third one is 1 by 3, as you can see it over here. The next step, as we discussed, was a benchmark data set or the golden data set. So I'm coming over here. So benchmark is standardized, reproducible test suite, and we know it very well. Right. So let me create a benchmark data set. Just like the earlier golden data set, I have created a benchmark data set. You can see ID, query, context, expected. In this way, there are total 10 over here. right? Belonging to 5 categories each, two of each. Then, as we said, the next step is what? I guess it's baseline evaluation. So now we get into the baseline evaluation. So here I'm going to use GPT-4 Turbo. I'm going to run on the full benchmark data set, not just a sample. And we'll be using the current production model and the prompt version, and we'll record everything. Model is this. System prompt says you are a Walmart assistant. Help the customers with product information. Store the policies and the order inquiries. Be concise, accurate. Base your answers only on the provided context. And then you can see over here, we are again giving a chat completion call. It will give the response. We calculate latency, input and output tokens. And this is what you have to do on the entire benchmark data set. So when I give a call to this, as you can see, it is going to run through all the benchmark data sets, getting the answer. Then we are giving the response to the judge LLM, which will finally get the response, which will be appended over here. So that's what I'm doing. I'm going to run the benchmark and it will print the base average, base latency and the base tokens. So on all the 10 sentences it is doing. So you expect it to take some time. 2 by 3, 2 by 3, 3 by 3, 3 by 3. So almost 40 seconds. So finally it is done in 46 seconds. Thing. The next thing which we do is the regression testing. So here we are basically rerunning the benchmark after changing to the system and comparing the new scores against the baseline. And then as we decided, right, the delta that we'll be looking into. So over here, let me change the model and run the things. Everything is same. The only thing is model name is changed from GPT-4o Turbo to GPT-4o Mini. And of course, this will run it again on all the 10. It will give you the results as well, but I don't have time to keep on comparing it manually, right? We got the results for the original one. 2 by 3, 2 by 3, 3 by 3, 2 by 3. That's what we have. With the Mini, also we are getting more or less the similar results, but it is still working together. Once it is done, we will compare straight of all. So 8 is done. Now, these are very straightforward questions. So more or less you are getting the same scores, but you can see the comparison and all those things, but don't see it over here. We got the results over here. We got the earlier results. I am straight away going to calculate the delta in the score. So here baseline results and comparison results are being read. And I have just written down a code where it is going to compare it point by point, and it will give a nice tabular analysis, right? So this is just alignment stuff. We are not doing any API calls. So baseline comparison, same. Aggregate delta, 0. You can see over here, the differences are more or less, it looks exactly same. Here, in fact, 0.667, this has improved comparison 1. And here, this was 1 and this is 0.67. It is regressed down and so on. So overall, hours delta, right? So this This is where we see the hours. It is saying investigate. That's the only thing that we see, and overall, it looks good. So, what do we actually conclude from the last line of the output is that, see, category delta is what? New model score minus the baseline model. When it says for the hours, it is minus 0.167, which means the performance dropped by 0.167. Basically, the new model performed worse for the store hours question. This means it is missing a timing detail, or it confused a weekday with a weekend hour, or maybe it gave incomplete answer, or it failed to mention special or holiday hours. So even though the decrease is only minus 0.167, the code's category level regression threshold has likely been crossed, and therefore the team must inspect it. What's exactly wrong? But overall, yes, the new model is stable. One category order which is improved, three categories stay unchanged, and one category for hours is regressed. This is what we understand. So the last step after that was a go or a no go decision, if you recollect. The last step was, last means second last only, but almost we are at the last, go versus no go decision. So here I'm setting up all of my thresholds for regression, aggregate, and critical. And I'm simply comparing the deltas for each of this. And I have written down my own logic for critical category blocked or aggregate quality regression or other things, right? I just regressed it, and this is where we understand the baseline model for turbo, comparison for mini, aggregate delta, regression 1, improvement 1, critical category is listed, latency minus 9674, token delta minus 6, decision blocked, critical category regression. This is what we understand, and hence you have it over here. Also, the last point, it saved the report to 11 benchmark JSON, which is over here. So to come back, I would say overall, I can say the GPT-4o mini, as per this evaluation, is faster. It uses fewer tokens as well, right, than the GPT-4 Turbo, but the deployment is still blocked because it performs worse in critical category called as store hours. That is the overall conclusion that we understand from this. Now, just a side-by-side comparison. We are done with the notebook, but this is just a side-by-side comparison. Comparative LLM as a judge, where I just want to do the side-by-side comparison. And we are just, basically all the things I have just stitched together, nothing great over here. My prompt, my API call. Then in this, I'm just finding out, see, both the models will be listed, both the benchmark scores are read out. Then comparative judge for the baseline model and for the next model is also being created. Then I'm checking whether both of them are winner or not. Let's look into the result, right? So with respect to the very first record by record, it's a tie. Comparison answer is slightly clear due to the inclusion of parentheses, though I have not printed the answer. The second one is where the GPT-4 Turbo, the base model, won. Third one is again a tie. The fourth one is where the mini won, and I did it only for the 4 records. I didn't do it for all. And that's what is the summary which I want you all to read through it before we get into the next notebook. next one. I'll upload it. Just give me a moment. Before that, I'll create a new notebook. Ninth, 10th, 11th, hmm, 12th notebook. Read the objectives once. All right. Let's go ahead. Now, friends, in this notebook, since you have read this, the problem statement of this notebook is pretty clear. We are going to observe, monitor, and debug a production agentic AI system such as Walmart Retail Assistant. So the assistant may involve several stages. And the stages is going to be like user query, then document retrieval maybe, then LLM call, then tool or API call, followed by final response. So when something goes wrong, simply knowing that the final answer failed is not enough. The team must identify which stage failed, why it failed, how long each stage took, how many tokens and how much money was consumed, right? Which exact request caused the issue. That all things we'll look into then. Now, what exactly this notebook is going to cover? So the topics that this notebook is going to cover is the first one is the traces, spans, and the events. Now, what is trace? Trace is one complete customer request. One complete customer request. So each trace contains smaller units called as spans, such as retrieval spans, LLM call spans, tool call spans, response generation span, and events capture specific movements inside the span, like a request being sent, a retry or an error being received, right? Anything. Then the second thing which we look into is the structured logging. So instead of storing the logs as plain sentences, the notebook stores them as structured JSON containing fields like timestamp, trace ID, span name, and all those things. So this will make the production logs easier to search and filter and analyze. Third is, as we always do, we will also be looking into latency attribution. Fourth one would be token and cost monitoring, because every LLM call consumes the input and the output tokens. So we'll be looking into the cost per request. Then this notebook also talks about the LangFuse integration. That's another important point over here. So you will be able to see how using LangFuse you can view the traces and the spans, latency, token cost, evaluation scores, and also the sessions and the prompts. And when LangFuse is unavailable or your keys are not configured, the system writes the traces to the local JSON-L file as a fallback. Then the next one is root cause debugging. So whenever user reports an incorrect answer, traces help determine whether the problem came from incorrect documented retrieval or lower relevance score, hallucination, right? LLM hallucination or any kind of tool failure, etc. Then the seventh one is the evaluation scoreboard and the dashboard. So in our notebook, let me tell you that we are going to combine the previous evaluation and the regression test into a new text file called as evaluation scorecard.txt and observability dashboard design.txt. So overall, if you ask me, the final objective of this notebook is to build an observability system that answers questions like what happened during this request, where did the problem occur, and what evidence do we have to fix it. Right. So now, the first and foremost thing which we have to do is I have to get all the environment variables set. So if you see over here now, in my env file, you see my API key. And we don't need anything other than that. We use the Pinecone API key, OpenAI API key. We use the Open Weather Map API key, Tavily API key. Now you would have to do it for the LangFuse as well. So from where do we actually do that? Well, you will have to go on to the website cloud.langfuse.com for generating this API key. I'm going to sign in with my Google account. And this is what I have signed in with my Google account. You can see over here, of course, before coming for your session, I have to practice. So I had created a short demo over here. So I created a short demo project, as you can see. So what you do is maybe you can create a new project over here, new project. I'll explain you what is LangFuse at the right time. Don't worry about it. I'll create a new project. Maybe I say that demo 9 July because I'm going to delete it. Create. When you create it, you have the option to create an API key. Click on that and you get the secret key, public key. You don't need to copy this, straight away copy this. If you see carefully, it has Langfuse secret key, public key, base URL. And I have the same thing copied. Same thing is being copied. Right. Langsmith is also for observability. Langfuse is also for observability. You have many other observability tools. Yes, some of your teams use Phoenix as well. For any thoughts on Langfuse versus Phoenix? Oh, yes, TS will help you out on this. Let me not invest time on that. So yes. So that's how you get this API keys in place. All right. Now, starting with trace or span or event. See, what is exactly a trace? A trace represents one complete request from start to finish. So, for example, let's say if I'm talking about trace, if a user asks, what is the price of the milk? Now, the trace starts when the question enters the system and ends when the final answer is returned. So you can think of trace as a complete receipt for one transaction. In the same way, the next is span. What is span? Span represents one individual activity inside the trace. Like, if I'm taking the same example, what is the price of milk? If that's the question asked, then for the milk price query, the possible spans are a call to the LLM. Second is calling the price lookup tool or preparing and returning the answer. So that's one thing. So, if you're considering, let's say you went to a restaurant and you got a bill, that entire bill can be called as a trace. Whereas, let's say you bought over there one pav bhaji, one masala dosa. So that one pav bhaji wala line, one item in that receipt is called as a span, right? That is called as a span. Okay. Then after that, the next one is an event. What is an event? So an event records something that happened at a particular moment inside a span. Obviously, I can give you examples to support it. Retrieval started, it's an event. 3 documents were written, it's an event. Timeout happened, it's an event. LLM responded, it's an event, right? So that's exactly what is an event. Then, now, if I, let's say, take Walmart specific example to explain these all. Let's say user asking for it, milk price. It's a trace. One span could be retrieval. One span could be LLM call. One span could be tool dispatch, and one span could be nothing but your response. Right? So this allows the team to exactly identify where the problem occurred. All right. Next. After this, the next thing that we are doing, I think over here, event trace and all, then span ID. right? Now, what is span ID? See, information stored for every span consists of the following things. Information stored for every span consists of the following things. Then getting started. So span ID is nothing but the unique ID for this individual activity. The parent trace ID will be connecting the span to the complete request. The name will be the name of the activity, like retrieval. Start time is when it started, end time when it ended, duration is the duration, status is whether it succeeded, failed, or timeout. And metadata is the extra details like the tokens, model name, etc., etc., etc. So this is what we have over here. Right. So that's one thing. The next is, if you see over here, we are using UUID over here for the unique traces. I know it can produce unpredictable tokens. We want sequential IDs, ideally T001, T002, T003, and so on. Definitely yes, but UUID4 produces unpredictable IDs, and kind of honestly speaking, it is safer and it reduces the chance of duplicate IDs across the distributed services. So that's kind of a good idea, I would say. Then now there can be some more things that you can add in over here and also along with this, right? So it doesn't end over here, but this is what I added. Of course, you are free to add n more number of things inside this. All right. Coming down. Now, this is where we are actually getting into the implementation part of it. So as you can see, I am creating a constructor. First, we are creating a class called as span, which is representing one specific activity inside the request. Then we are having a constructor having the name, trace ID, and the metadata. As you can see, the span ID, as you can see, which is obtained using the UUID, right? Then trace ID is there. Then we are also having the name. Then we are recording the time and all those things as obvious as it should be, including the metadata as well. Then we are adding an event, right? Don't we record the event ID, right? Yes, of course. So we are adding an event over here, and that is what we are doing. So I have defined a method for recording a point in time event inside the span. So this event is going to contain the name, the UTC timestamp, optional event data, which you can add more. And then also I have a finishing of a timestamp, which will mark a span as completed. By default, the final status is success. So I'm going to record the finishing time and update the status. And I will add or I will update the metadata when the span finishes. Then I have the span duration. You also see there is a add the rate property decorator, which allows the method to be accessed like a normal attribute, right? And then finally, I convert the span to a dictionary. So this was for a span. In the same way, I am creating a class for trace. Now that goes without saying, we are adding the same things, but this is for a specific trace, converting it back to a dictionary. Using Langfuse, this happens in an automated way. But yes, first we are doing it exactly as proposed in the outline. So that we are going in a logical incremental order. The next is What is structured logging? I assume everyone knows, right? What is structured logging? Logging it in such a way that reading it from the structured logs is easy, right? In the form of key value pairs, something like this, rather than like this, right? Rather than as an unstructured text, structured logging is this. And we all understand what we actually mean over here. We have been doing it since our RAG notebook as well. What to remember, these pointers are important for you in a long run, so I will not hesitate to go through it. Log at info level for every span, start end. Log at warning for slow spans, and log at error for exceptions. Always include the trace ID in every exception traceback. Do not log PIIs, and set the log per level environment, like debug in dev, info in staging, and warning in the production. So as you can see, we are getting into the structured logging part over here. So this code is creating a JSON logger for the Walmart agent. So instead of printing that, okay, the tool has failed, we will print it in a nice structured way, something like this. So if you look into the code now, first we are importing the logging module. That's, I think everyone knows. Then I'm defining a logger class, structured logger. Then we initialize the logger. Name is saved. Level is saved. Default is info, right? Then self dot underscore logger, where we are creating or retrieving a logger with the given name. In our case, the name is Walmart agent. Then we are also, if you see, right, I'm saying if not loggers dot handle. So this is for avoiding adding duplicate handlers. So that's what we are doing. So as you can see, we are creating an instance of the stream handler, and then h.set formatter is where I'm printing only the message content. And then there is an internal emit method. It's a private helper method which creates and writes one structured log. Then I'm creating that log over here. And then we have the get ettr, where I'm writing the log at the correct level. Then we have some public logging methods, info, warning, and error. I assume everyone knows this, right? So info is for recording normal operations. Warning is for recording slow LLM response, retries occurring, etc. Then we create a logger, trace ID. As you can see, we are taking it. Then I have a retrieval, which is the start log, where I say log.info for retrieval. Span start, query is milk price. And I'm extracting the top 3. Then you have the retrieval end log, which is showing the successful completion of the retrieval. Next, you have the slow LLM warning. I'm purposely adding it. And lastly, you have a tool timeout error. Right. No. You can see over here, all of these things. As expected, we are just simply logging it. Then we'll be doing it using Langfuse as well, right? But this is the starting part of it. The next, we talk about what is latency attribution. We know what it is, but just going through a couple of things over here. The practice of breaking down total end-to-end latency into contributions. We have just looked at this some time back as well. Like in the retrieval, the budget is 300 milliseconds. So, the retrieval is, as I told you, right? What did I tell you at that time in retrieval? RAG retrieves in less than 5 milliseconds. Less than 5 milliseconds. Still, I have kept as 300 milliseconds. That's the budget. So That happens because it uses what you called as HNSW technique, which funnels down quickly from thousands of vectors to hundreds to tens to top three quickly. LLM, you can see straight away 5 times more time, 1500 milliseconds. LLMs easily take 1.5 to around 3 seconds for the answer to come. Tool dispatch 500 milliseconds, and so on others. Read the disclaimer. By disclaimer, I mean what to remember. Always measure latency at span level, not just end to end. Report P95, not the average. And at P99, that is 10x, the P50 indicates an intermittent external dependency issue. So I'm gonna save all of these statistics first. So as you can see, importing the statistics module. See, basically what are we doing in this current code is I am measuring where the Walmart retail assistant is spending time. So it is answering two questions mainly. Is the complete request meeting the response time SLO? Then which stage? Retrieval, LLM, tool call, which is causing delay. So I imported statistics so that I can calculate mean, median, average, etc. Then I'm also defining the latency budgets and the latency alerts, which we just defined in the about table. Then we have latency report. So this function is going to receive multiple trace records and create a latency report. So it will basically have two collections, span latencies and total latencies. Span is where we are storing the timings stage wise, and total is where you are storing the complete request duration. Okay. So, for example, you can expect the things to be saved, something like the span latencies for retrieval for the LLM call. And then after that, you read every trace, process one complete customer request at a time, store the complete duration of that request. If the duration is missing, use 0. Then process every internal stage inside the span. If no span exists, then you create a new span, right? And then I'm also creating an empty list for the new span name. And then I'm adding the current stage duration to its category. Then finally, we are checking the end-to-end latency over here. So as you can see, first I'm sorting, calculating the length, calculating P file, all other things. This median mean is coming through statistics. And then we are also reporting all the budgets. So for that, I'm randomly taking 5 fake traces. In real life, obviously, you'll be having the real traces coming. And you can see over here how we got the latency attribution. So what do we understand from this thing? If you look over here in the latency attribution report, it says end-to-end P95 is 3699, SLO is 3000, and SLO breach is true, which means 95% of the requests are completing within about 3.7 seconds, but the target was 3 seconds. So the system is missing its latency, or it's missing its latency SLO. Then you also have stage-wise interpretation if you see carefully. in retrieval. Average was 324, budget is 300. So budget used is 108.1%, so slightly over budget. LLM also 1639, but expected was 1500. So over budget. Tool dispatch 624. Again, we are going above the budget. Highest percentage over the budget is this. And business budget 100. We are 109. Slightly over budget. This is what we understand. And you know why no flag appeared over here? Because the alert column is blank. And that's blank because none of the stages crossed their alert thresholds. For example, LLM alert threshold, if it is 2500 and the actual average is just 1639, then the stage is definitely over budget, but it is not reaching an alert. So that is what we say. Then then just give me a moment. Okay. And with this, the next thing is, yes, the next thing is the token cost tracing. So let me add it. Now we all know what do you exactly mean by the cost tracing, right? We have been doing it right from the session 1, and we know the costing for each of the model as well. So now, going ahead, I know the model pricing for each of this. I have taken it straight away from the OpenAI's pricing page. So if you go on to OpenAI pricing on Google, it's gonna take you to the pricing page. So you can get the costing for GPT 5.5, which is $5 per 1 million token for the input understanding. For the output generation, $30 per 1 million token. So I have taken the inspiration from there and I have written down the model pricing over here. Then we have been doing this input token and output token calculation since a long time. So I'm not going to re-explain it. I have just modularized it. And then here is the place where I have traced the LLM call. So I'm creating my new span, adding the event, and I'm having a system prompt that you have to answer only using the provided context. We are giving a completion call with the following hyperparameters, calculating the costing, adding the span, finishing the span, also performing the logging at the info level. Then as you can see, we are creating an instance of the trace. You can see over here, I'm trying out various spans over here. First one is I'm tracing for retrieval and I'm finding out how much time it takes for completion. Purposely, I'm inducing sleep. LLM call, getting the result. And this time I'm again showing the span, again inducing the sleep so that I can see the result step by step. And then we are just putting everything into a dictionary and calculating the total cost over here using the upper created metrics. So as you can see, what is the price of great value milk? Total time is this, span is 3. Price of this, total tokens consumed 65 for input and 16 for output. Cost is this, and the projected daily cost, if you are going to do it at a scale for 100,000 queries, it's going to be $113. So we are computing it. But yes, you will have to keep on updating depending on your model and depending on your charges. Rest, everything remains the same, except these things can be changed. Then, after that, finally, we get into the last part, which is Langfuse integration. So these all things are done manually, and we understand we are taking in a lot of efforts, but it was a part of our TOC. Can we automate this thing? Can we automate this thing? Automate in the sense, you understand, right? We are just thinking about putting the things on a platform which is ready-made available for us. So friends, getting into Langfuse. A ready-made skill for coding agent, managing your prompts, traces, and evals through natural language. No manual API call needed. Open source AI platform. This is what you have in over here. You get a nice observability over here. You can see over here, you have a lot of things available. So essentially, it is nothing but an observability platform for the LLM as well as the agent applications. And it will help us to see what happened inside each request. So all the efforts that we had been putting in this notebook, which of course I know neither you nor me, we are going to do that. We will most of the times be using the available platforms, but sometimes, if the client says that we don't want the data to go out of the system, you may be forced to implement everything manually. So here we are getting into the Langfuse integration. As you can see, it is nothing but an observability platform built for the LLM and the agent applications. So you can clearly see over here which spans were executed, how many tokens were used, how much request cost, whether the answer passed the evaluation, and all those things. Right. So plus you can do the score logging. Evaluation scores can be attached to your trace. You can calculate faithfulness, relevancy, toxicity, task success. Cost analysis can also be done because Langfuse also tracks the token usage and cost by model, cost by user, cost by session, environment, and everything. So let's say prompt version 1 has lower accuracy, prompt version 2 has better accuracy and higher latency. So it also supports the controlled A/B testing instead of changing the prompts directly in the production. Langfuse, as you can see, it's an open source platform, right? So obviously there will be no cost associated over here. Plus alerting can be done, integration platform, all of these things are available. So now the best part is when it comes to using the Langfuse, you can use Langfuse in both the ways, Langfuse cloud or self-hosted. On cloud, zero setup issues. You don't have to worry about it. But if you are doing it locally, then you need the Docker and the Kubernetes for the setup, right? Here, you only have the infrastructure cost. You don't have anything. So if you don't want anything to leave your system, you can do it completely locally as well. I'm using the Langfuse cloud for quick deployment. All right. So now, getting started. The first and foremost thing, here, getting into the code part. So what are we doing? The first thing is I have said LangFuse available equal to false. So essentially what am I trying to do is initially LangFuse is unavailable, keys are missing, and I'm writing some default fallbacks over here. Right. But of course, I'm going to set it as true. So next thing we are checking whether the keys are available. And if the keys are available, create an instance after importing and say LangFuse is available. Then after that, you straight away have a class which talks about fallback observability. So that's the fallback logger class. It's going to create a backup observability system. It writes each trace or score as one JSON record per line. So, it's basically you can expect this class to write the output somewhat in this format: trace ID ABC, status success, trace ID ABC, metric faithfulness, value 0.93, and so on. That is how it will keep on adding on to the JSON-L format. You can see over here, while initialization only, I have given the default path. Okay. So if it is not able to log it to LangFuse, it is locally documented. So that's the best part of it. So I'm having a method over here, which is called as log trace. This is going to accept one complete trace dictionary. So I say over here with self.path.open a, which means open in the append mode. And then I'm writing it to the JSON file. And then you can see over here later on, once we are done with this, I'm saying log.info. So log.info means I am going to log that fallback, and it's going to create a structured log showing which traces was saved, that the fallback was used, which file received the record, etc. And then after that, I'm going to get that particular trace ID. So if the ID is missing, it uses question mark. And then finally, you are also getting the log score for it. So I'm saving the evaluation score. So one score connected to one trace. Then I'm also creating after that a fallback observability logger. So that is using a default path, by the way. Then I have the main observability function over here. And here you can see we are first checking, is the LangFuse available? And the moment I say it is available, I am preparing the trace ID. I'm transforming the trace ID into a normalized format. And by normalized format, I mean to say over here that in case if you have something like this, it would be converted into this format. You can see that the moment that is over, I am going to create the main LangFuse event. Now, in my case, I have connected to my Walmart project, right? So here, if I get into projects, I guess this is the one where I am connected. And now let's come in over here. So I am first of all going to create an event. So this will create a top level LangFuse record for Walmart request. Then post that, once we have created that, the next thing is we are also connecting the event to a normalized trace ID, and we are also creating a name. Input, as you can see over here, right? User query is stored as an input. And metadata also I'm adding. So I'm copying all the trace level information except the spans. If you see over here, I have clearly specified if K is not equal to spans. It's a very standard code. You don't have to worry about it. Similarly, I do it for spans. And then here when you get if scores. So I'm sending the evaluation scores. Now that they are computed, I want to send it to LangFuse. So I'm saying that for metric comma value in scores dot items. So process each of the score. So if you have faithfulness, if you have answer relevancy, all of this are going to be simply added on to the LangFuse. Also, you can see there is a else part for a fallback where I'm gonna write it to the local file. You can see over here. And I run it. So you know what? Once this is done, we are able to do that. So overall, if you see the flow was something like this. You check the keys, then you tried creating the LangFuse client. If it is available, you send it to LangFuse. If not, you log it locally. That is what is the idea. One question for you before we proceed. LangFuse becomes temporarily unavailable while the Walmart assistant is serving the customers. What should happen? A, B, C, D. Absolutely correct, because the business should continue while the observability data is saved through the fallback mechanism. That's absolutely correct. All right. Now, before we proceed, I think something which I wanted to show you. Okay. One moment, I'm getting it. Just give me half a minute. All right, and now I want you all to just keep the chat box empty for some time. So yes. All right, so coming to it. Now I'm going to do a little bit different thing in between. I'm stopping the notebook. We want all the audience to be with us. Tomorrow we have a capstone. So even before I conclude, I have a very small but important request for every one of you. See, let me tell you that whenever you think of delivering a class, a lot of content in a short amount of time, a lot of thought, planning, preparation, and efforts they go in designing and delivering the sessions like this, because this is advanced production level training. The most meaningful way you can acknowledge this effort is by sharing your honest feedback and your thoughtful feedback. So I really want you all to take out a few minutes time, I would say, today, right now, not later, and complete the feedback form using the link shared in the chat box. See, I'm not asking you to give only positive ratings. I request you to fill out the form sincerely and from your heart. Please mention what you genuinely appreciated. Please mention what was most useful. Please mention what could be improved. Your specific comments are far more valuable than simply selecting a rating. Your feedback helps me understand whether my efforts created a meaningful learning experience for you all, as well as guiding me for my future sessions to be even more better. So please don't skip this. Take a moment, kindly reflect on your experience, and share your best and most honest feedback right now. Thank you so much for appreciating the efforts, I would say, and for contributing with your valuable thoughts to this in advance. Once you are done with it, I would request you to kindly acknowledge. Oh. I don't know. Sujay, I want you to interrupt over here now. Hi, Sujay. Hi, Sujay. Wow, what a life. Link not working. Need to call him now. I was been requested to share it well before the class ends, but unfortunately, the link is not quite surprising how come this happened. But anyways, give me a moment. API key is also not working. All right. One moment. Yeah, Sujay is joining. It's right on it. So I'm not sure, Nitya. Is it because you filled it on the first day? Honestly speaking, I never filled it up and the link didn't work for me either. So I think only Sujay can help us out over here. The type form is now closed. Yes, even I can see the same thing. So I guess it's closed only.
Yeah, hi, Dr. Darshan. This is Sujay here.
Please take it ahead. They are saying that the type form is closed and even I can see the same thing.
Yeah, hi. Madam, what's the concern?
They are saying that the type form is now closed, and I'm also getting the same thing when I click on the link.
Okay, yeah. So I remember this feedback was shared on the first day and we filled it. That's correct. So basically, the same feedback on the first day it was being shared to understand your feedback so that we can improvise from the second session. Now that we are in the last phase, which is the fourth day, I request everyone to please provide feedback considering the 4 day training session, the entire 4 day training session. Even though you have filled, you can still click on the same link and provide the feedback. Yeah.
But the link is itself not working, Sujay. If you try clicking on it, it says the type form is now closed.
Oh, okay. Just give me. No problem. What I'll do is I'll just check with the Typeform team and then get this sorted. I'll share it over the email so that we can get and we can also collect it tomorrow. That shouldn't be a challenge. That's
All right, no problem. Then I'll continue.
okay. Let's not spend time on this. We can go ahead. And any which is I'll be sharing them the recording. So during the recording, I'll also paste the updated link. Yeah.
All right, perfect.
Thank you.
Welcome. So as you can see over here, observability by level, cost by model, cost by type, user consumption, all these things are ready to be gathered. Now, yes, taking a step ahead. Now the next section is about root cause debugging with the traces. So what I essentially mean when I say root cause debugging by the traces over here, the idea is now I'm trying to make you understand how to investigate a bad response using a complete trace instead of guessing. So the step number one, as you can see, we find the trace ID. So whenever a user reports a bad answer, first request is the unique trace ID, which can come from the support ticket for the application log, user session, could be anything, right? Then you retrieve the complete trace. So you load all the spans for that request from the Langfuse fallback JSON file, etc. And then you inspect the retrieval. You check whether the correct document chunks were retrieved. You can ask the questions where any chunks retrieved, was the correct output produced or policy retrieved, and many other things. Then in the step number 4, you can inspect the LLM input, right? Then after that, you can inspect the LLM output, raw output of the LLM. Then the tool execution can also be inspected. Then evaluation scores is what you inspect: faithfulness, answer relevance, robustness, task success, relevancy, etc., etc. So you look into all of these things. So the main takeaway is the traces allow us to move from the answer was wrong to this exact stage, this input or this tool caused the wrong answer. Right? So that's what is the biggest advantage over here. So what are we doing now? If you look into this, I have created a function called as debug trace. So we are inspecting a trace and identifying the common problems. So, some of the common problems that we are identifying over here is, what if no documents were retrieved? Or we have a very low retrieval relevance, slow retrieval, slow LLM response, excessive token usage, etc. So we created a function, debug trace. All the issues and signals. Issues are the detected problems. Signals are those useful measurements such as the token count and the retrieval score. So we are saving it. So, just as an example, when populated, your issues can look something like this. And when populated, your signals may look something like this down the line. So I am going to go through, process every span, right? Every span, right? Inside the trace, we are going to look into, I'm going to get the metadata, get the name of it. Then I'm also going to have the retrieval span. And what are we doing in the retrieval span is I'm checking the number of retrieved chunks, score of the highest rank chunk. And the default values which I have given are 1 and 1.0. So the missing metadata does not immediately produce a failure. Then I am also detecting 0 retrieved chunks. I'm also detecting over here a score less than 0.6, which is a low retrieval score. So if the best chunk has a score below 0.6, then the retrieved context may not be trustworthy. Then I also detect after that a slower retrieval, as you can see here. And then I'm adding the slow retrieval issue. In the same way, I have the LLM span added over here. So if name is equal to LLM call, then I'm calculating the input and the output token usage, and I'm immediately adding them to the report, right? In the signals you can see. Then to detect a slow LLM, we are again calculating the latency and the difference. I'm calculating the token usage. Depending on that, I'm adding it to the issues. If it's an error, I'm adding it, and ultimately I'm returning it. You do all of this. Then after that, I finally give a call to the above function, debug trace, which is nothing but this function. Call diya. You give a call, and this is going to print a detailed report. So issues are LLM slow, and this is what we already got. We have seen that earlier. Exceeds the alert threshold. Signals, as you can see, as I showed you. Similarly, debug problem for report trace issue. Issue is what you see over here. Right. Then I also have finally the evaluation scorecard. So where will I get the evaluation scorecard? From notebook 10 and 11's JSON file. So if you remember, this notebook 10 JSON file was there. We have all of these scores. So you can see everything is going like a story. And the notebook 11 JSON file, which we have all of this baseline model comparison versus the other one. So I am going to aggregate all the metrics from 10th and 11 into a single reference document suitable for the stakeholders. So reading both of this, as you can see, loading it. If it is available, I am just fetching the data from each of this. Similarly here for notebook number 11. And then I'm finding out the total and deciding whether it is pass or fail. So first of all, it loaded for both. And overall, we got 9 on 10 metrics saying it has passed. And to generate a final scorecard text file, right? Using all of this, this is just, I've just decorated it nicely, to be very honest. So when I do this, all of these things get saved into the text file, which I can show you over here. This evaluation scorecard. Very nicely saved, right? So I just taken efforts to just stitch it nicely in the form of a report. Of course, you can straight away ask a LLM to generate a report. You need not do this much. But that was, I took some additional efforts for you guys so that I can show everything systematically. And this is what we essentially understand from this. I can also kind of draw an observability design. So again, we are just, putting it in a nice manner once again. Over here, a design for perfect dashboard. Right? This is just for quick understanding. And that brings us to the end of the notebook, showing what all have we discussed. In fact, by the time you're reading it, I can also move on to the Langfuse. Maybe I can consider refreshing it. Initially, only 2 traces were there. And now, if I get into the Walmart, why is it not updated? 4 scores track. Traces, demo 16 April. Yeah, quite surprising. I'll refresh it. It should have been updated. In fact, when I see it on the browser, I see it updated here. I don't know why it's not showing me. No worries. I'll show you why it's not reflecting over here, that I don't know, but have a look at this. See 11 traces, Walmart returns router, Walmart observability. So you have all of these things in place. So if I straight away load this, God knows why it is not updating over here. It should have, but there it was showing, here it is not showing. So now when you look at this, let's try to understand what we are finally having over here. So here, if you see over here on the Langfuse home for our Walmart project, total 11 traces are being tracked. So that's one thing. So user, let's say if it is asking for the product price, then retrieval can happen. LLM runs, tool is called, final answer is returned. So this chart is showing us how many traces came from different workflows such as Walmart return flow, router flow, temporary observability flow. All of those things is what you see over here. Also, if you look into the model cost, what is the costing? 0.000325. This is the model costing over here. So the dashboard also shows, just give me 10 seconds, please. All right. So yeah, the model costing, as you can see, token used is also given 1.14K. That also is one thing that you can see. Token use 1.14K. It can be easily observed. Also, the total spend is in USD. Scores also, you can see 72 are being totally tracked. And the visible metrics, as you can see on the dashboard, answer correctness, relevancy, faithfulness, supervisor answer correctness, router answer correctness. Faithfulness average came out to 0.93, right? You can see over here. This means also this means that the answers were strongly supported by the available context on an average. So on, you have others as well. Then if you come down, you have the observability by time. right? So this includes the spans, events. This also includes the model calls recorded inside the traces. Now, since one trace may contain several spans, the number of observations is usually higher than the number of traces over here, right? Then after that, you also see the model usage cost by type, cost by usage by type, consumption, scores, latencies for all the P50, P90, which we have done manually, as well as using this generation latency percentile, observation latency percentile, the model latencies in case if you are having various models. Finally, you have the score analytics as well. So all of this comes over here whenever you ask it for. And that is essentially how you look into this stuff. So because we have completed this 12th one, adding the file for the 12th one, over here. Right. All right. Could you all quickly confirm if you are able to see all the resources added over here? Yes or no? At least I can see it on my GitHub. So if you are able to see that, just quickly confirm, then we are good to call it a day. All right. Any questions for the day? Anyone having any kind of questions, feel free to let me know. Tomorrow we have a capstone, right? So there will be 1 or 2 notebooks that we do in the initial 1 hour. Then there will be a capstone. So basically, if you understand all the previous notebooks that we have done, understanding the capstone is simpler. If not, then it's going to be a little challenge. But since you are going to work in groups, I think it is still doable, right? If you work on each of the modules one after other in group, I'm pretty sure we are able to cope for it. All right. So if there are no questions, then we are good to call it a day. Thank you so much for your time. And I see you tomorrow, same time, 9 a.m. Bye, everyone. Thank you so much. Thank you, Jay, Vijendra. Thank you, Manjuna. Thank you, Shweta. Bye. Bye, Gautam. Athal. Thank you, Ananya. Thank you, Atul. Thank you, Marzook. Thank you, Mani Chandrakant. Thank you, Devika, Prashant. Thank you, Anaya, Anuj. Thank you, Janvi. Thank you, Abhilasha. Thanks, Rohit. Thank you for attending, everyone. Thank you, Gajendran. Yes, bye, Subramaniam. Thank you so much. So I take your leave, Elvian. Bye, signing off.